Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electricity from May-June 2021, paper 2-1. For part A, we need to state Kirchhoff's second law. Kirchhoff's second law simply tells us sum of EMFs. EMFs means if we have more than one electrical source in the circuit, that has to be equal to sum of potential difference, or simply we can say sum of TDs in a closed circuit. So we also need to mention in a closed circuit, we can say in a closed circuit, or we can say in a closed loop. In a closed circuit, or you can also say in a loop. Now this question has 2 marks. The first mark is for this part. If you have written sum of EMFs is equal to sum of PTs, you will get 1 mark. And this is M mark, means it must be in the answer. And the second mark is answer mark. So this is second mark. But if you cannot get M mark, you will also not get A mark. So M mark is must mark, means it must be in your answer. And the A mark is depending on M mark. If you can't get M mark, you will also lose A mark. Let's try to understand Kirchhoff's second law with the help of one simple circuit. So let me draw one circuit here first of all. If you look at this one very simple circuit, let's say the EMF of this cell is E and this resistor is R1. If we connect voltmeter across this one, let's say the reading on this voltmeter is V1. And this is the potential difference across this resistor. And now if we look at this closed loop, in this case simply we can say the EMF is equal to the potential difference across the resistor. So this is our closed loop. So simply we can say in a closed loop, in this case, in a closed loop, or we can say in a closed circuit, EMF is equal to V1. Means the EMF is equal to potential difference. We can also extend this idea to 2 resistors. Now let's connect 2 resistors across this cell. So this is our resistor 1, and here let's say we have another resistor. We can say this is R2 and this is R3. If we connect voltmeters across these resistors, and let's say the reading on this voltmeter is V2, and this is telling us the potential difference across second resistor. And we connect another voltmeter, and that one is across third resistor. Now, if you look at this closed loop, means if we start from here and we form a closed loop. So this is our closed loop. Now, if you look at this closed loop, we can also say that in this case, EMF is equal to V1 plus V2. If we have more than one power source, then we will say E1 plus E2. Let's say we have 2 power sources. In this case, I can also connect another source here. Let's say this is another cell that is connected here. So this is E1 and this is E2. And so the EMF of this cell and the second cell, we will say in this case V1 plus V2. So simply we can say the sum of EMFs in any closed loop, sum of EMF is equal to sum of PDs, and this is Kirchhoff's set, and this is how you need to state. For part B, it is given to us the wire XY, means this wire XY. The resistance of this wire is given. Simply we can say the resistance of this wire is 0.90 ohm. So this is resistance of this wire. It is also given to us the potential difference across XY. This is equal to 1.8 volts. It simply means if we connect voltmeter across this wire, means between X and Y, the reading on this voltmeter, this is equal to 1.8 volts. Now question is asking us, we need to find out how much current is passing through this wire. So very straightforward one. Simply we need to use Ohm's law. We will say V is equal to IR. V is the potential difference across the wire. So simply by using Ohm's law, we can find I. From here we can say I will be equal to V over R. V is the potential difference across the wire. R is the resistance of the wire. So the potential difference across wire is 1.8 volts. We need to divide by the resistance of the wire, that is 0.90 ohms. So our final answer in this case will be 2.0 amps. And this is the final answer. This question has only 1 mark. If you have got the right answer, you will get this 1 mark. So simply we can say up to 2 SF, this is 2.0 amps. For part B, we need to calculate the number of free electrons that pass a point in the battery in a time of 45 seconds. First thing we need to understand, the current leaving this battery is I and current entering this battery is also I. And value of I we have already calculated, that was equal to 2.0 amps. Time is given to us, time in this case is equal to 45 seconds. So T is equal to 45 seconds. We need to find out number of electrons. So we can start from here. Q is equal to IT. But we need to find the number of electrons. So Q we can write down. Q will be equal to N times E. N is the number of free electrons and E is the charge on single electron. So we can say NE, this is equal to IT. We need to find out value of N. So simply we can rearrange. We can say N is equal to IT divided by E, and E is the charge on single electron. I is given to us, this is equal to 2, and the time is given, this is 45 seconds. And the charge on single electron is 1.6 times 10 to negative 19 coulombs. If we simplify this one, our final answer will be 5.6 times 10 to 20. And this is the number of electrons. And this is the number of electrons passing through a point in 45 seconds. So our final answer is 5.6 times 10 to 20. This question has 2 marks. The first mark is if we have written Q is equal to IT. So this is C mark. We will get 1 mark. And the second mark is answer mark. And this is for the right answer. If you have got right answer, you will get 2 marks. For this part, we need to calculate the resistance of capital R. Simply, we need to find what is value of this capital R. For this purpose, we simply need to use Kirchhoff's second law. According to Kirchhoff's second law, in any closed loop, as we have discussed in part A, in any closed loop or circuit, sum of EMFs simply we can say sum of EMFs has to be equal to sum of PDs, potential difference. If we look at this closed loop now, we can first draw this loop. This is just one loop, so let's redraw this one loop. In this loop, we only see one EMF, and that is 4.0 volts. Now, if we go across this wire, for this wire, potential difference across this wire is given in the question, and the value of that is 1.8 volts. So we can simply write down here, or we can simply say VXY, potential difference across this wire, plus the potential difference across capital R resistor, and we can say this resistor is small r because this is internal resistance. We can denote this one with small r. So this is I times R. Now simply we need to plug in values. So we have 4.0 and VXY, it is given in the question, and that is equal to 1.8 volts. I in the question we have, this is 2 amps and this is the capital R, the resistance. I also the same passing through this internal resistance, so this is also 2. And the value of R we have, that is 0.35 ohms. Now if we simplify for R, our final answer for R will be 0.75 ohms, and this is our final answer. So this is 0.75 ohms. And the first mark you will get if you have written this one. So this mark will be C1. And the second mark you will get if you have got the right answer. Simply speaking, if you got the right answer, you will get 2 marks for this question. For part C, we need to calculate total length L of wire XY. But for this question, it is given to us the connection P is moved along the wire XY. It simply means that we started moving our slider from this point and we keep on moving this one until it is at point P. Now it is given to us the galvanometer reading is 0 when the distance XP is 0.30 meters. Means the distance between X and P when this is equal to 0.30 voltmeter. The reading, if we connect voltmeter across XP, means between X and P, the reading on this voltmeter is equal to 1.20 volts because this galvanometer reading is equal to 0. So this is what question is telling us. What we need to do is we need to find the total length of wire XY. But in the previous part, we have already calculated the potential difference across XY. Means simply if we connect voltmeter between X and Y, the reading on this voltmeter is 1.8 volts. We have already calculated in the previous part. In order to answer this question, you need to understand the ratio between VXP and VXY is equal to the ratio between LXP and LXY. But for this question, it is given to us that LXY, this is equal to L. So simply we can say LXY is equal to L. Now we need to find out value of L. So simply we can say in this case, L will be equal to VXY multiplied with LXP divided by VXP. VXY we have that is equal to 1.8 volts. We need to multiply with LXP. LXP is 0.30 meters. We need to divide by VXP, and the VXP is 1.2. So this is 1.2. If we solve this one, our final answer will be 0.45 meters. So this is the final answer. This question has 2 marks. The first mark is if you have written in this form, means if you have written the ratio between VXP and VXY and the ratio between LXP and LXY, these are equal, you will get 1 mark. So this is C mark. And the second mark is answer mark. This is for the answer. If you got right answer, you will get 2 marks. Let's try to understand a little bit more about potentiometer and especially about this relationship, I mean how we got this one. So let me explain you this part. Simply we can say that VXP, this is equal to I times R. Here we are talking about XP part of the wire. We can say current in that part and resistance of that part. We can also write down VXP is equal to IXP times the resistance. That we understand resistance is equal to resistance of any wire. This is equal to rho L by A. So we can write down here this is rho and A is the cross-sectional area of the wire. We can say this is AXP. And we can simply write down VXP in this case. This is equal to IXP times rho times LXP, and this is divided by AXP. So this is how we can write down VXP. We can also follow the same procedure for VXY. For VXY, we can say this is equal to IXY times resistance of wire XY. I is the current passing through wire XY. So we can write down this IXY. Resistance we can write down this is resistivity times length of the wire XY divided by the cross-sectional area of the wire. So we can say this is AXY. So this is VXY. Now we need to understand for these two wires what is the same. For the same wire, now we can say for same wire, because in this question we are talking about this wire and this is the same wire. Simply this is the same wire. We are talking about this same wire, and for this same wire now we need to understand what is same for XP and for XY. The first thing we can say that in this case IXP, this will be equal to IXY, or simply we can say this is equal to I. Second, we need to understand AXY because the same wire and the cross-sectional area of the wire is uniform. So we can say AXP, this will be equal to AXY, or simply we can say this is equal to A. Rho is also the same because we are talking about the same wire. So it means rho XP, this is equal to rho XY, and we can simply say this is equal to rho. Now simply we need to divide. So we can write down VXP. If we divide VXP by VXY, we can also say this is equation 1 and this is second. So we can say 1 divided by 2 means equation 1 divided by 2. So we can write down these things here. So here we got I, and this is rho, and this is LXP. So this is LXP, and this is divided by A. AXP is equal to A. And we need to multiply this one with A divided by I times rho, and this is LXY. Now from here, simply we need to cancel. So you can see I is here. We can cancel with I. Rho we can cancel with rho. A we can cancel with A. So we left with Vxp over Vxy. This is equal to Lxp divided by Lxy. That's the reason we wrote ratio between Vxp and Vxy is equal to ratio between Lxp and Lxy. So this is how you can derive this one. So simply let me write down again here. So we will get Vxp divided by Vxy. This will be equal to Lxp divided by Lxy. Means the ratio between potential difference is equal to ratio between L. For the second part, it is given to us the fixed resistor is replaced by a different fixed resistor of resistance greater than capital R. We need to state and explain the change, if any, that must be made to the position of P on wire XY so that the galvanometer reading is again 0. We can divide this question into two parts. First thing we need to understand, when the resistance of this resistor is increased, what is the effect of this one on the potential difference between X and Y, means on the reading of this voltmeter. So if this resistance increase, the potential difference across XY, it will go down. So this is the first thing we need to understand. The potential difference across XY, this will go down. We also need to understand that the ratio between Vxp and Vxy, this is equal to Lxp by Lxy. From here we can write down Lxp. This will be equal to Vxp times Lxy, and this is divided by Vxy. But if you look at this question, it is given to us that Vxp is not changing. We want the same Vxp. Mean this one is not changing. Lxy, the length of the wire, this is also not changing. But Vxy has decreased. So if this has decreased, so Lxp has to increase. This is how you can write down your answer. So we have simply mentioned PD across XY decreases, as we have discussed here. PD across XY decreases. So if you have written this one, you will get 1 mark, and this is B1 mark, means it has to be in your answer. The second mark you will get if you have written P is move towards Y, mean this P you have to move to the Y, or simply you can say to the right. So you will get the second mark, and second mark is also B mark. It has to be in your answer.